Okay, what we're talking about here is a concept called the net force. And the net force is defined as the summation of all of the forces acting on an object. So this sigma symbol here, it's a Greek letter sigma, and it means sum. So it's the sum of all forces that are acting on an object. So let's take an object here. Let's say it's a box. And we're going to put it on the ground, and let's say, for example, I push the box this way with a force of 10 newtons. Okay, and let's say somebody else comes along, much stronger, and pushes a little bit greater force, 15 newtons. And then let's say there's a force acting on the box from this direction of 5 newtons. So the question then is, what is the net force? So what is the net force on the box? Well, the net force, net force, that's the total or complete force, is going to be the summation of all forces. So what is that sum of all forces? Well, we've got 10 newtons going to the right, so that's plus 10. And then we've got 15 newtons going to the right, and then we've got 5 newtons going to the left, so there's a minus 5 newtons there. So we're going to sum up the 3 forces that we have acting on this box. If we do that, we have 25 newtons positive minus 5 is going to give us 20 newtons plus 20 newtons in the positive direction. So the net force, the force net, is then going to be 20 newtons this way, or plus 20. And that's how we calculate the net force. So let's take another example. Let's say, for example, we're going to, let me clear this for a minute. Let's do this. Okay. Let's say we have something sitting on an incline. Well, before we do that, let's just take an example of something that's hanging from a rope. Let's say it's hanging from a pulley. So here's my pulley, and someone's on this side holding it. Now, here's an object. Let's do a free body diagram. There's the force, of course, of gravity. So the force that's due to gravity, let's say in this case, let's say it's 20 newtons. And then there's an upward force the box is experiencing, or the object's experiencing, from the rope. And let's say that rope is pulling up at 15 newtons. Okay, so the question is, what's the net force acting on this object? Well, the net force, again, is the sum of all forces. In this case, we've got 20 downward, so negative 20 down, and we got an upward force of positive 15. So the net force is minus 5 newtons, or 5 newtons in the downward direction. So we just calculated the net force acting on that box. Let's try something a little bit more challenging. All right. Let's say we've got an inclined plane here. Trying to just do this freehand. And let's say the plane is at some angle, let's say 20 degrees. And there's a box that's sitting on this inclined plane. So this is like a board that's slanted and there's a box on it. So if you lift the board up, the question is the box going to fall and slide down the board? Well, we really don't know just yet. But what we were asking to do is to calculate all the net forces. So let's start putting in the forces. The first force acting on this box is the force of gravity. And gravity, we know, just goes straight down because the force of gravity pulls objects right down to the earth. So this is straight down, and this is going to be F for gravity. I'm not even going to put any kind of magnitude on it. Let's just say it's gravity's pulling the box that way. But now the board that the box is resting on is pushing on the box upward. So the board is pushing up like that on the box, and let's call that the force normal to the plane that the box is sitting on. All right, that's the perpendicular force. If this is the plane is putting an upward force perpendicular to the plane on the box. And then, of course, there's another force that we didn't talk about yet, but we are familiar with it, called friction, and we'll call that force of friction. So the object of this game here is to find the net force, the net force acting on the box. Well, the way we're going to do this is we are going to draw ourselves a little coordinate axis. And I'm going to I guess I'll do it in blue here. And we'll put a coordinate axis along this route. Make that the y-axis, and then along this route, let's say we'll do it this way. Going to be our x-axis. So we could picture this here as our x-axis and picture this blue over here as our y-axis. Now if I tilt this guy to make it a little more easier to see, I'm just going to kind of rotate this whole figure that way. I'm going to kind of rotate it. So we're going to have the axis is going to look like this here, and like this. All right, where this is going to be x and this is going to be y. So here's my x, here's my y. And now I'm going to show, I'm going to do that. I'm going to show my box is going to be sitting, let's say the box is right here. That's where I showed it. All right, so we have straight upward on the box. We have the normal force, the force that's perpendicular. So we have one force that's acting in this direction, and that's the normal force. You see, then the force of friction is acting this direction. So that's going to be our force of friction. And then, of course, we have the force of gravity acting like this. So there's force gravity. Now remember, gravity's not acting at an angle. I just rotated this guy up so that we could see it a little bit easier. But now let's look over here. This makes a right angle. So if you look at it this way, all right, and we make a right triangle, and this is 20 degrees, how many degrees is this angle in here? Well, it's going to be 180 minus the 90 minus the 20. So 20 plus 70 will equal 90. So 70, 80, 90, and 90 make 180. There's 180 degrees in a triangle. So if that's 20, that's got to be 70. So this angle right here then is going to be 70 degrees. This angle here is 70 degrees. Okay, so far so good. Now we're almost done. Last thing we want to do is draw in. Now we got to take this force of gravity and we got to separate it into its x and y components. So this is going to be the x component for gravity. This vector right here is going to be the y component. So this is force of gravity in the y direction, force of gravity in the x direction, and the x and the y components are going to make up this vector right here, FG. So now that we've got this coordinate system, we can find the net force. So let's do that. Let's say the net force in the x direction is going to be F sub g in the x direction minus the force of friction. And the net force then in the y direction is going to be the normal force minus the force of gravity in the y direction. Because you have the normal force here, and here's the force of gravity component in the y direction. Now what is the F sub, let's see, I was doing it, I think, in green. Well, anyway, this will work. The force of gravity in the x direction is going to be just the force due to gravity times, that's a g, times the cosine of 70 degrees. And the force of gravity in the y direction is going to be whatever the force of gravity is times the sine then of 70 degrees. So we've got the force of gravity in the x, force of gravity in the y. This is going to give us the net force in the x direction, the net force in the y direction, and then what we'll come up with is some force net in the x, I'm not sure which way it's going to go, some force net in the y direction, and of course we can then figure out what that overall net force is total acting on the body by doing the Pythagorean theorem and finding out the magnitude of this. Okay, so we'll do some more problems a little bit later.